Hello, welcome to channel Databots. Today we're going for the phase 2 of the networking. In previous phase 1 we have seen the TCP and UDP fundamentals, and today we're going to discuss the parent or the conceptual model where these protocols are based on OSI and TCP IP layers. In this phase, we are going to cover the OSI model, TCP IP model, and where we are going to use the TCP UDP in these models. And the coding part that we are going to learn in this phase, gRPC. And we are going to give a, I'm going to give a quick intro on gRPC, and after that, we'll understand some end-to-end flow of any messaging service. Here in this case, we are going to take the WhatsApp Messenger as an example. So let us get started with it. So the OSI model is the conceptual model where the roots of network interactions is based on. OSI, in short, is the base framework to understand network interactions, and it can be defined, or its full form is Open Systems Interconnection. And one thing we need to understand whenever we are learning any kind of architecture, in real world everything is horizontal, and whenever it comes to representation everything is vertical. So let us go through the seventh layer, application layer. In application layer, we have the application services that interact with us that we can see. We have protocols like HTTP, FTP, file transfer protocol, hypertext transfer protocol. You can see the link here. It is an HTTP protocol based link, and whenever I want to send some files or download something, I'm going to use FTP. Here the this is the abstracted layer where user can interact with, and this is the presentation layer where the data is translated. Let's say I want to send a message. It needs to be encrypted and sent to the server because nobody can't should access this and read this. So the redundant things that need to be done for further processing are, are done here in the translation layer. We have protocols like SSL and TLS in the presentation layer, secure socket layer, and in the session layer, connections that are established between the software and hardware is maintained. Let's say I have login to my GitHub account, and during that time the login session is remembered by the layer. Anyway, we are not going to use this architecture in real world applications. The information related to the user that is maintained here, and here comes the middleman transport layer, also known as the heart of OSI. This is where TCP UDP lies. Using this layer, end to end communication happens between the layers above and the layers below. So this layer is widely used for transport. And coming to the three other layers, network, data link, and physical layer. Here, everything related to the processing is done. In networking layer, we have components like routers and logical addressing, because everything in the computer is a physical address that needs to be mapped to a logical address so that we can access it, and the language that can be understood by other applications. These things are done here in the network layer, and these two layers are pure hardware. Here we have data link layer. Here we handle errors, add physical addressing like MAC, like MAC address, and here comes the layer where hardware lies. In this layer we have cables, switches, and other stuff we see. These are the things that you need to understand before going to something else. Even though this is conceptual, this is the base model for everything you see in the real world. This model is further abstracted. It has 7 layers, and this is abstracted to 4 layers for simplicity. And even though these are in the diagram, in real world these are just applications that are connected, and this architecture can't be seen through real eyes. It's just how the things are divided. This is the OSI layer, and let us go to the TCP IP model. As I said, 7 is converted to 4 in the TCP IP model. In the application layer, we have all the stuff related to the presentation, application, and session. You can see the Chrome browser has everything related to it. If you open the inspect, you can find the cookies that are related to the session, and for presentation we'll get the presented info encrypted here, and the application logic HTTP FTP all can be seen in a single layer in TCP IP. That's application layer, and transport layer is independent, TCP UDP, and network is independent. Here the algorithm related to the networking are applied, like routing. We can also see something like I think it's BGP, and data link and physical layers are interfaced together as network interface, and in many sources these names may change for TCP IP conceptual layers, but at most there are 4 layers, and this is a hybrid model from the OSI reference model. And the third question is answered here. Transport layer is the layer where TCP UDP fits, that handles the user and physical devices transport of data. In TCP, we'll send the data and get acknowledgement. We'll send a stream of data, and in UDP, we'll send a datagram. Both of them have different kinds of headers. So technical this is the conceptual part that needs to be understand beforehand. And the next thing we are going to see is grpc. This is the real deal, even though it doesn't teach you much about networking, but you kind of really love this whenever the phase 3 begins. grpc lies in the application layer, the seventh layer of the OSI model. And it is an open source framework allowing communication between server and client. Using this, we can support features like bidirectional streaming between server and client, and multiplexing. If you don't know about multiplexing is actually is this taking same so many values and converting it into a single value is multiplexing, and taking a single stream of value and converting it to many is demultiplexing. Next up, we're going to take a simple example to understand the end-to-end flow of networks. Let us take WhatsApp. Let us take an individual person. The app you see is application layer, and the message content that is encrypted is the presentation layer. And after that, a session is maintained. So whenever I use WhatsApp, I didn't get logged out because a session is maintained solely for me. And validating the session, the server and I can communicate with each other. So this is the user part. Most of this can be felt by the user, and these messages are sent as packets using the TCP IP. So until the message is reached and I get an acknowledgement, I don't get the blue ticks. And this message is sent to another phone. So I need to find the IP that I need to send, and for that I'll use the routing, and network layer helps me for that. And after network layer handles these, will it will go to the data link layer, where we have the bits divided into frames to check if there are any missing data errors. And in the physical layer, let's say it's kind of another phone or a Wi-Fi router. This is the physical device where this data is reached, and it handles demultiplexing and multiplexing the data. And after that, using the same process, it is sent to another phone. So this how it goes. This is the end-to-end packet flow with a simple example. Here in this case we have WhatsApp. So before going to grpc and learning some stuff, these are the conceptual things that needs to be understood. And I'll give you a simple breakdown. We have two things: REST and grpc. These aren't actually different, they try to do the same thing, but the way they deliver the data is different. In grpc we use something called protocol buffers, and in rest we have this architecture called request and response. These are most widely used in public apis, web apps, web apps and grpc is used in cases where speed matters, most widely used in microservices. So before going to something, please understand the different protocols used in writing apis. So this is my advice. Thanks for watching. Stay tuned for the phase 3. In phase 3 we are going to deep dive on grpc. Thanks for watching. Thank you. Stay tuned and like, share, and subscribe. Thank you.